Okay, hi, good day everyone. Today we're going to be doing the summary breakdown of number 9, paper 2, CSEC Math questions. Right now, for these type of questions, um, right, number 9 is a section 2, paper 2 question. The topics being tested is what's the topics being tested is trigonometry. Right. So the section being tested is section 8, which is geometry and trigonometry. Right? To be exact, what is being tested on is circle theorem, circle theorem, circle theorem, right? Then you have your cosine rule, your sine rule, bearings, and in this bearings you may have to apply your types of angles. And what I mean by types of angles, I mean like to spot interior angles, um, alternate angles, those type of things, right? So these are the things that are being tested on. Now for your circle theorem, there are 5 theorems that you need to remember. Theorem 1, the angle at the center is twice the angle at the circumference standing on the same arc or chord. So the same um, if you have the same chord and they have a angle being produced at the center and an angle being produced at the circumference, you just need to know that the one at the center is twice the size as the one of the circumference. Right? The angle in a semicircle is a right angle triangle. That means if you have a circle and you have a diameter, and that diameter is a side of a triangle, the angle opposite that diameter is going to be 90 degrees. Theorem 3, angles at the circumference of a circle on the same arc or chord are equal. So if you have the same arc or chord, now again, a chord is when you is a length of a line that goes from one side of a circle to the next side without going through the center, right? And it produces two angles that are at the circumference. They are equal. Right? Theorem 4, opposite angles of a circle quadrilateral are supplementary. That just means if you see a circle and you see a quadrilateral, opposite sides are supplementary, meaning if you add up those two sides, it's going to be 180. And then theorem 5, the exterior angle of a circle quadrilateral is equal to the interior opposite angle. Right? So if you have a cyclic quadrilateral and you have a line being extended, the angle that is opposite the interior angle, the interior angle that is opposite that exterior angle, exterior angle, sorry, exterior angle would be equal. Right? So that is the rules that you need to learn, and you need to learn how they say this, right? Because some questions, especially with CSEC, they ask you to give reasons for your answer, so you do need to remember these terms, right? Maybe not exactly word for the word, but you do need to know the concept of it, right? Some things that you need to remember is tangent lines that intersect by the diameter or radius is perpendicular. So the radius and a tangent, or the diameter and a tangent, will form a 90 degrees. The sum of interior angles of a triangle is 180. So if you see a triangle and you have two um, two angles, you can find the third angle by adding up those two and adding up those two and subtracting it from 180. Right? The isosceles triangles, two sides are equal. equal. Hence, two base angles are equal, and straight line is 180 degrees. Right, now your sine rule can be, sine rule and cosine rule is used for triangles that are not 180 degrees. Okay, now for your sine rule, once you have a side and a corresponding angle, right? So if you have so when I say a side and a corresponding angle, if I have side A, my corresponding angle is angle A. That is the angle opposite that side, right? If I have B and angle B, or if I have C and angle C, right? And they give me, let's say, they give me that combination of a side and its corresponding angle, and they give me an angle, and I want to find the side, I can use the sine rule. Right? So if two angles and the length of one side corresponding to one of those angles are given, of the length of two sides of a triangle and the angle corresponding to one of the lengths that they give you, you can use your sine rule. Right? Your cosine rule can be used to calculate unknown sides or angles in a triangle that does not have a right angle triangle. Again, that's what I just now said. If they give you all three sides, if they give you all three sides, you can use cosine rule, or if they give you two sides and an included angle. What that means is that they give you two sides, and when those two sides intersect, so if they give you this side here, right? If they give you this side here and they give you this side here, this angle here is my included angle. My included angle is the angle formed by those two sides given. Right? Now the formula that you have to remember is this. This, please note that this is found in your formula sheet. So if you're not able to remember, please notice in your formula sheet. This one is not found in your formula sheet. However, it's just making cos A the subject of the formula, and that's how I got this. But if you can remember it, that's great. Excuse me. Alright, so did I get this? I have A squared is equals to B squared plus C squared minus 2BC cos A. I always go but whenever I have to make something the subject, I go backwards from BODMAS. Is there subtraction? I want cos A to be positive. Cos A right now is negative, so I'm going to carry this across. So I have 2BC cos A plus A squared is equals to B squared plus C squared. I want A by itself, so I'm going to carry across that plus. So I carried across the subtraction. Now I have addition. So I have 2BC cos A is equal to B squared plus C squared minus A squared. Then I have multiplication. All of this is being multiplied, so I'm going to carry it as a group. Carry this across. Opposite of multiply is divide. So again, B squared plus C squared minus A squared all over 2BC, and that is how I got this formula here. So again, if you have this formula, all you have to do is make cos A the subject and you'll get this formula. So it's not like a different formula, it's just a rearrangement. Alright, so now we will go on to bearings. There's a few things to remember for bearings. Bearings has to do with the direction of the cardinal points. To be exact, cardinal points is north, south, east, west. The angles taken into consideration, the unit of angles is always degrees. The direction of bearing is always clockwise, never anti-clockwise. It's not the shortest distance between two angles, it is always clockwise. If you go anti-clockwise, you'll get it wrong. The original point that it is starting is always go in a north or upwards direction. So you draw that north line, and then from that north line you will measure your bearing. All north lines are parallel, hence, so if you have two north lines, let's just say this here, and this comes a lot, you have point A with a north line going up here, and then there's a next north line going up here, and I know this angle here and they want to find out this angle. These two lines are parallel and I have a transverse line going through it, hence these two are interior angles which are supplementary. So if I want to find angle A and I know this is 50, I would say A is equals to 180 minus 50, so A is equals to 130. And that is how, this is what we use, especially in bearings. They love to bring questions like this, so make sure that you understand that north lines are supplementary and sides of the triangle that are given are your transversal lines that intersect these parallel lines. And we know that if you have a transversal line intersecting parallel lines, the angles on the same side are interior angles, hence they are supplementary, right? Which means that they, if you add them up, it's 180. Right, so now let's start with the past papers. So this here is January 2025. Let's read the question. The diagram below shows a circle with a center O and points P, Q, L, and N lie on the circumference. LN, and is equals to NQ, and MR is a tangent to the circle at L. Angle MLN is 63. So immediately I know that from what they're saying here, PL is your diameter. And what was the rule for your diameter? The angles opposite the diameter is 90 degrees. So we know what that means is basically P and L is equals to 90 degrees. Yeah? That is this angle right here. They also told us that NQ and NL are equal. Hence, these two angles are equal because they would form an isosceles triangle. So, ISOSCLES triangle, isosceles triangle, base angles are equal. Yeah? What else do we know? Base angles are equal. We also know that PL, which is your diameter, would intersect the tangent at how much degrees? How much degrees? Right? The diameter, PL, the diameter intersects the tangent, right, at 90 degrees. Which basically tells me that PLM and PLR are both 90 degrees. Okay? Then we have, I'm seeing two chords, a chord NL produces two angles, right? Two angles at the circumference, hence they are equal. And when I say they produce, if you look at this chord here, NL, it produces one angle here. It's the two sides of an angle, and this is also the next side. So I know that this angle here and this angle here would be equal. Do you understand? So, is there any other rules? No. Let's read this first one. Explain why angle X and angle NQL are equal. That's immediately the last one. Chord NL. Oh my gosh. Sorry. Chord NL produces two angles at the circumference, hence they are equal to each other. Right? And that's the answer there. Let's go to the next one. Alright, let's do it. Zoom, zoom, zoom. Oh, zoom out. Determine the value of each of the following angles. Show detailed working where possible and give reasons for your answers. So you see everything that we just now wrote down, they want, if we're using it to find angle X, that is what we have to do. Alright, so I am going to take this, copy it, I'm putting it here. Right. I'm also going to take the image of the thing so I don't have to keep on going back and forth so that we can use it, right? So I have it here. So we can use it whenever we like, right? Let's zoom in. Angle X. Now, we know that this entire angle here is 90 degrees. Yes? We know that is 90. Can we calculate this angle here? We also know that this is 90 and this is 90. So this angle here, PLN, so PLN plus PNL plus NPL is equals to 180. PLN, we don't know as yet. That would be 90 minus 63. You seeing that? Right? PLN, PNL, that's this one, is 90 degrees plus X is equals to 180. 90 minus 63 is 27. So 27 plus 90 plus X is equals to 180. So X would be 180 minus 27 plus 90 is 117. So X would be equals to 63 degrees. Right now, this is what we have here, but they want reasons for your answer. You have to say PNL is 90 because it's opposite the diameter. I am not writing that back. I'm just going to copy and paste. This here. Then we have to say why is the 6. We know that, right. This here, copy. We have to also say the PL, the diameter, intersects the tangent at 90 degrees. So therefore PLN and PLR would be 90. We know that PLN was PLN plus PL, sorry. Yeah, this would be 90 minus 63, right? And that is how we get this. And then we know interior angles are always 180 degrees in a triangle. Angle Y. Right, now if this is 63, then here is also 63. Why? Because chord NL is producing this angle and this angle here. This is an isosceles triangle, so therefore this angle here is also 63. So angle Y would be equal to 180 minus 63 plus 63, which is 180 minus 124, which is equal to 180 minus 124 is 56. Right? So what do you have to say? First, you'll have to say chord NL produces two angles, hence they are equal. copy, right? You'd also have to say hence x and nql are equal, right? Then you would have to say the thing about isosceles triangles, the base angles are equal. So that's how I got those two are equal. And that is the reasoning for that so far. And then, of course, the interior angles, the sum of interior angles in a triangle is 180. And that is it for the first part. Do we understand this so far, Sean? So this is part B, which as soon as you see something with that has not, it's some bearings type question, right? The two ports E and G on ground level, 245 kilometers apart. So E and G, 245 kilometers apart. The bearing of E from G. So they're telling you you see when they say from G, you're starting at G and ending at E is 302. So what we know when we are looking at the bearing, we always go, as I said, in a clockwise direction. Never in an anti-clockwise direction. So you have to go around and we're going to E and they said that's 302 degrees. Understand? A ship is anchored at F, some distance away from G on a bearing of, so the bearing of um, F from G is 228. So they're telling you from here to here is 228. So we know the distance from the north line to the E line is 302 and the distance from the north line to the F line is 228. So it is clear to see that we can find the difference between these two. We're going to give you this, right? 302 minus 228. Let me put a 302 subtract 228. 302 minus 228 is 74. So that angle there is 74. Do we understand that so far? Anything confusing about this? Alright. 74 degrees. Angle, this is 52. So if this is 74, this is 52, then this here, we see a triangle. So it is 180 subtract the summation of 74 plus 52, which is 180. 180 subtract 74 plus 52 is 54. So this angle here is 54 degrees. Right? We good so far? So from everything that we know here, we have seen these are the things that we could calculate. Also, can I calculate this angle here? If from the north line to E is 302, I can calculate. Let's put this in red so we can see. We may not need these things, but I'm just showing, right? This here, this angle would be 360 minus 302, which is equals to 58. Yeah? 360 minus 302 is 58. Do we understand everything that I have found out so far? Anything that is confusing? So we may not need these things, but from the information that is given, we can calculate these things. Yes? Okay. On the diagram above, insert 228 bearing of F from G. We have that. That's this angle. That's this part here. Determine the value of FEG. FEG, that's this angle here. We already did it. It's 54. Right? So you see, we did need it. Right? So, and that's one mark. So you just needed to say EGF F was 302 subtract 228, which is equals to 74, and FEG is equals to 52, sorry, not 52, is FEG plus 74 plus 52 is 180. So FEG is 180 subtract 74 plus 52, which we calculated already, which is equals to 54 degrees. And that is how you do this question. That is 1 mark for you to be understanding everything that they gave you here. Alright, they want this one calculate. Now, usually when they do this, when they ask you for the length and stuff, it is some bearing. It is not bearings, it is sine rule and cosine rule. Okay, so let's take an image of this, everything that we have here, and I'm going to put it in the next page so that we can do it. Right? Make it small so we can see when I zoom up. Right? Zoom, zoom, zoom. So we're seeing everything. Now let's just bring this around right here so we can have the entire place and we have the image as well. Calculate FG. FG. Now FG. Now I told you that if for cosine rule you have to have at least two sides. Do we have two sides? No. Right? So it's most likely sine rule that we have to use. So if I have an angle and its corresponding side, which is 52 and 245, I can find out, and I have an angle and I want to find out a side, I can do that, right? So I know the side, which is 245. Let's use black. 245 over sine, the angle corresponding with 245 is the angle opposite, which is 52, would be equal to, you're trying to find GF over, what is the angle that corresponds with GF? 54. So sine 54. You carry this across, so GF is going to be sine 54 times 245 over sine 52. Right? Make sure that your calculator is in degrees. So sine 54 multiplied by 245. You press your ABC button for over. Sine 52. You press equal. They will give you that GF is equals to 251.531039. We want it to one decimal place, so GF, unless stated otherwise, as the standard, so 251.5 kilometers to one decimal place, and that is going to be your answer for this question. Do we understand the sine rule? Right, this question says indicate the point F on line EFG such that GH is the shortest distance from G to EF. So they are basically saying indicate that point F is on EF, this line here, such that GH, so it's going from G to H, is the shortest distance. Now, it's up to you. You can use a ruler and put the tip of the ruler on G and see which one, drag it along the line of what it is, EF, and see which one would be a shortest distance, right? This is not drawn to scale, so don't take it. So if you go here, it's too long. If still too long, still too long. Here is there, but anytime you go above, it's increasing. So it is a straight line that forms at 90 degrees. Are you seeing it? So F would be, you take G and you draw a straight line. Alright. Alright, and you know that this here is 90 degrees. Right? So now let me take this image, because this is what I'll need. Hold on, I need to label this F. It's not F, it's H, right? GH. Alright, so now we're going to take an image of this. We're going to use this to answer the questions. Add X, delete that, X of that, and let's put the new image here. Obviously, when you're in exam, you can turn back and forth to see. Because I'm on a computer, I don't want to go back and forth, right? I just want to see the image right there. They said determine the distance of GH. Now, immediately, because it's a 90 degrees angle, you're supposed to think, oh, they have this side here, which is 251.5. 251.5, which we found before, right? And they want GH, and we have angle 52. So we have a triangle that looks like this, 251.5. That is opposite your 90 degrees, so this is definitely a hypotenuse. They have this angle here, which is 52, and you want to find this is G, this is H, this is F. You want to find the side that is opposite 52, so this here is opposite. So you will put so, ka, toa, right? It don't have adjacent, so anything with adjacent, so A is out. So it'll be sine 52 is equals to GH, because that's what we're trying to find out, over 251.5. You want to find GH, you carry this across, so GH would be 251.5 sine 52. Right? When you do that, 251.5 sine 52, that is, GH is 198.184745. You wanted to, they didn't ask you to the nearest kilometer or anything like that, so one decimal place, 198.2 kilometers to one decimal place. And that is the answer for determining the distance of GH. Alright, let's see if I think that is the end, and that is the end of number January 2025, number 9. So we are going to end here today.